Okay, so doing a standard deviation and a mean and all those things from a frequency table is a little bit different. We've done it for mean, and your calculator will just give you the standard deviation right out of that. All right. So in the textbook, there's a big nasty formula that I never even gave you, right? And I'm not going to hold you responsible to know this formula, but you do need to be able to do it using your calculator. So the formula is that the standard deviation is equal to the square root, and it has n times brackets the sum of fi xi squared. Does this look familiar?
Yes.
Yeah. And you were thinking, God, I hope I don't have to know this. And then it's the same thing, but quantity squared. And then divided by n times n minus 1. I will not hold you responsible to know this formula. Now, in my other class, people were asking about, do I have to have this memorized? What do you think about memorization when you get to have a cheat sheet? Right? But you don't even need to worry about putting this one on your cheat sheet. The regular standard deviation formula, I would put that one on there. Right? Because I could have you do standard deviation, show the use of the formula, and give you like 4 observations or something. You make a little table and all that. But you may have to compute the standard deviation using a frequency table. And that's what this is for. The Fi is for frequency. Right? So the frequency of the ith observation and the value of the ith observation. And let's use as an example. Do you remember in class last time we did, I had you raise your hands about number of siblings? Somebody grab your notes and tell me what those values were, and we'll just use that. So we had some people that had 0, right? Oh, we didn't?
No.
Oh, that's right. This class, there were none of those. Right? Nobody had 0 siblings. And then we had 1, 2, 3, 4, 5. And where did we get to stop?
8.
That's what I was thinking. It was clear up at 8. 7, 8. Okay? And what were the frequencies? 10. 9.
3. 2. 1. 0. 1. 1.
Okay? So what this means is there were 10 people who had 1 sibling. There were 9 people who had 2 siblings, and so on. All right? So, and what's the sum of these? 27. Okay? So that's our n. N is 27. Now, in this formula, the Fi are these numbers. The Xi's are these numbers. Now, one of the homework problems that you'll have to deal with has, I'm just looking in the book, but it has classes that have a range. So it's class of 66 to 72. And the next one is 73 to 79. Then what are your X's? The midpoint. So X's are midpoints. And how do you find the midpoint of a class? You just average the lower and the upper. So the average of 66 and 72 is, what, 69? Right? So you'd use 69. And then average of that is 76. Got it? So it'd be just like this, but first you have to get a single number for the X's. Now, once you get that, what do you do to do this with your calculator? It's okay, they're cheap. What? Put these into L1. Put these into L2. And then what?
2 variable stats.
Almost. Not 2 variable stats, but 1 variable stats. And we will never use 2 var stats. But it seems like you would, because I got 2 variables here. Well, I don't. I got 1 variable, and I got frequencies of that variable. So this is considered a variable. So you're going to go stat, calc, and then 1 var stats. Right? So then on your screen, you're either going to have the older version or the newer version. The older version, you're going to do L1, comma, L2. If you have the newer version, you're going to say, I think it's list, L1, and then freq list, L2. Does that look right? So go ahead and do that real quick. You may have that data already in a list from last class, so you don't have to re-enter it. But do the 1 var stats. Tell me what the mean is, and tell me what the standard deviation Sx is. And that's this thing. It's going to use this formula when you have a frequency table.
Mean is 4.
4 even? Oh no, I bet you didn't do the L2 part.
Oh, okay. No.
Right? And that's a common mistake. He just did 1 var stats on the X column on L1. And the mean would then be 4, halfway between, right? But if you look at this as sort of a histogram, my tallest bar is going to be a 1. Next tallest is a 2, so the mean is probably going to be somewhere, maybe 2 point something, but 2 point. Okay, give me 2 decimal places. 2.41, just so that everybody knows they're matching. And then what's Sx? 1.82. Okay, so this is from this formula. Okay? Now, I don't, in an intro stat class, we really don't teach formulas that much anymore because software does everything. So it's really the interpretation of things that's more important. So I'm really impressed, and I'm proud of you, and your mother will be proud of you when you get 1.82. But what I really want to know is, 1.82 what? What is that number telling me?
It's the average amount of signals.
No, that's 2.41. 1.82 what? What is this a measure of? Not a measure of siblings. Okay, you said variance, and I'm going to change that word to variability. It's a measure of variability, or spread. Now, why did I change from variance? Because that has a really specific meaning. What is the variance? It's the square of the standard deviation. It's the thing you get before you take the square root. And we call that, it has a special name, variance. Right? So this is a measure of variability. So the mean number of siblings was 2.4. But the spread around that 2.4 is 1.8 in each direction. Right? So having 1.8 children less than 2.4 or 1.8 more than 2.4 is not unusual at all. Plus and minus 1 standard deviation. That should be about 68% of the data if you have a symmetric distribution. This one's clearly not, but all right? So everybody understand what standard deviation is and how to interpret it. That's what's important. Okay, does that answer your question? All right. Any other questions? Okay, then we will launch into today's section, which is 3.3. And 3.3 is measures of relative position. So what do you think that means, relative position?
Its position based on the position of something else.
Okay, and that something else is the rest of the data, right? So how tall are you?
5'11".
5'11". Ooh, well, he picked a good one, right? What's his relative position to the rest of males in the population? That's what we're talking about. What do you think, 5'11"?
Short.
Short? I'm 5'9", man.
52nd.
Average is about 5'11". It's about 5'10" point something is right around, right? So let's look at your data. I think I have, maybe, there it is. Oh, you can't see it. Here's male height from your data. There were 139 males, and the mean was 71.45. So 5'11" is 71, right? So what's his relative position? It's pretty much right in the middle, isn't he? His relative position is about 50% of the data, or let me not say the data, 50% of males are shorter than him and 50% are taller than him. He's about at the median, right? Or the 50th percentile. So that's our first measure that we're going to talk about, are percentiles. Now, percentiles, you've heard of percentiles practically your whole life, right? Percentile is a value that has that percent of the data below it, at or below it, right? So the example that I worked up wasn't from height, but because I don't want to have to deal with the gender thing and split my spreadsheet. So let's talk about pulse, right? If I go to the summary statistics for pulse, which are right here, we see that the mean was 67 points. That's height. That doesn't look right. That must be male and female heights together. There it is. So for pulse, the mean was 72.38. The median was 72. Right? Then down in this part, it says quantile. So in statistics, any word that ends in "ile" means you're dividing the data into equal parts. And then the prefix before the "ile" tells you how many parts. So quantile is the generic word. Percentile, how many parts are you dividing into? 100 parts into percents, right? So the max is 126. The 90th percentile, the software tells me, is 88. So what does that mean?
That at or below 90% have a pulse of 88.
Okay, I'm going to put the at or below in a different spot than you did. But 90% of this data has a pulse at or below 88. Got it? That's what we mean by percentile. Okay? So how do we find it? Well, let's start with an easy one. To find the value of the pth percentile, that's the way the book says it, not me, the pth percentile. Let's start with the 50th percentile. The book does not use this notation, but I say P sub 50 if I want the 50th percentile. P sub 90 for the 90th percentile, and so on. So, the first step is to find the location in the ordered data. So let's start with a really easy data set. 1, 2, 3, 4, 5. There's my data set. And they're already in order. How about that? What's the median? 3. Right? So let's use one that's easy to do to figure out, well, what would the formula be? To find the median pulse, I don't have n equal 5. I got n equal 365. Right? So what do? Well, you find the location. Well, I know it's going to be the third one. So how do I get the third one? The location, L, is equal to whatever percentile you want. So I want the 50th percentile. So 50 divided by 100 to make it a decimal. And then multiply by your sample size. All right? So this number, I have a 50, but that's, in general, that's capital P. Okay? So P divided by 100 times N. So for this little data set, that's 50 over 100 times 5, which is 2.5. The location in the data is the 2.5. No, if there's a decimal on the end of it, then you go to the next whole number above. So this is how you deal with odd number, even number kind of thing, right? So, actually, let me put it down here. If L has a decimal, use next larger whole number.
So you always round up then?
Right.
Even if it's like 2.1?
Even if it's 2.1. You go to the next whole number bigger than that value. Right. This is just to find location in a data set. Right. So L is 3. So I go to the third observation. There's my median. Now let's do it for pulse. Here is the spreadsheet of your data. And I've already, because I already had one class this morning, I've already sorted the pulse column. But do you know how to do that in Excel? You just put your cursor, I'll do it. You put your cursor in any cell in the column you want to sort by. Then you go to the home menu. Then over here is sort and filter. So you click that and then sort smallest to largest. Right? And it's already there, so it won't do anything. But right, so now I see that my very smallest pulse was 40, and it goes bigger and bigger and bigger and bigger, and down to the 365th one, which would be the max value, which was a 126. What value do I need to go to find the median? Work it on your computer. What value do I need to go to? What's the location in the data of the median? Use this formula to find L, the location. 365. So N is 365. What'd you say? 183rd. Very good. So let me slide this over. L equals 50 over 100 times 365, and you don't get a whole number, do you? You get 182.5. So you go to the next whole number. 180 observation. That's L. Okay, everybody get that? All right. Now, before I go to the data and do it, what if, I never finished down here, what if L is already whole? Well, let's add a 6 to this and see what you do. A lot of people struggle in math classes because they just can't remember all the little, well, if it's this, then you got to do. So I always say, take it back to something really simple and figure out what you do. Don't rely on memorizing and figure it out. So I have a really small data set with an even number. Now what do? Well, I take 50% of 6. 50 over 100 times 6 gives me 3. Do I use the third observation to get the median? What would the median in this data set be? 3.5. So I can't use the third observation. What do? If it's a whole number, then you use the average of that location and the location right after that one. Right? So if L is whole, average the Lth and L plus 1. I don't know if those are words or not, but maybe it's L plus first. L plus 1th? I don't know. L plus 1 observation. So if we had had 366 observations in this data, half of that would be 183. So our median would be the average of the 183rd and the 184th observation. Got it? Yep.
So for L, it doesn't matter if it's an odd number, it's just L's a whole number.
L has to be a whole number. That's right. So L might not be a whole number when you start. So if it's not a whole number, it has a decimal, then you just go to the next larger whole number. If it's already a whole number, then you're going to average to get the median or any other percentile. You're going to average that one with the next one. So L, you always make it whole in the end. But good question. All right, so let's do it in the data. I need to find the median, I need to go to the 183rd observation. Now, I have the first row has headers in it. Otherwise, I could use this column of numbers over here as just the observation number. But since one's already used, then my 183rd observation will be at row number 184. So I'll just scroll down to row number 184. There it is, and it is 72. So the 50th percentile is 72. Okay? Software had already told us that, so we knew what answer we were shooting for. Okay? That's pretty easy. Now let's go the other direction. What if you have a number like 88 and you wonder what percentile a heart rate of 88 is? Or you got an ACT score of 30 and you wonder, I wonder what percentile I'm at. Right? So you already have the value, now you want to know what percent it is. This way is going the other way around. Here they give us a percent that we're supposed to find, and we go find the value that has that percent. Now we're going to do the inverse of that. Okay? So oh, I'm sorry. Before I do this, I was going to have you find the 90th percentile. You do it with no help. Find the 90th percentile, and you can tell me what row I need to scroll to for you. Okay? Everybody getting that? What'd you get, Guillermo?
I don't remember the total number.
365. Okay. What's your name?
Kayla.
Kayla. And what's your name?
Claire.
Claire. Okay, Kayla, what'd you get?
3.9.
Did you get that? Okay, awesome. That's the right number. So you took 90 over 100 times 365, and you got what?
328.5.
328.5. Not a whole number, so you go to the next whole number up. So L is 329. Now I need to scroll to the 329th observation, which would be the 330th row. Right? So the 330th row is right there. 88. Okay? So the 90th percentile of heart rate, resting heart rate, is 88. 90% of the population should be at or below 88 beats per minute. Now, I want to use that example to go the other direction. What percentile is a pulse of 88. So now we're going the other direction. Okay, first step, find L equal number of data values less than or equal to 88. How many data values are less than or equal to 88? And again, to do this by hand, you need a sorted list of the data. You got to put the data in order first. So if you have software like Microsoft Excel or whatever, you can use the sort function to do that. Of course, as soon as I say that, I think, well, if you got software like Excel, it's got a percentile function built in. Just use that. But hey, this is to make us smarter. Okay, so I go to 88. Well, what do you notice about 88?
There's several data values.
There's several of those. In fact, if I scroll down a little more, the last one is right there at row 340. So that's important to remember that this has an equal on it. It's less than or equal to 88. So how many data values are less than or equal to 88? 339, because this is the row number, so it's one less, right? So 339 pulses less than or equal to 88. So L equal 339. Now you just undo the calculation to solve for P. Right, so P is L over N times 100. And then you round that to nearest, not necessarily always up this time, because it's P, not L. Round to the nearest whole percent. So L is 339. N is 365. Move the decimal by multiplying by 100 and tell me what you get. Okay, and before you went to 93, you had 92.8. Okay, so let's go ahead and do that. 92.8. So P is 93%. Okay, so 88 is the 93rd percentile. Does that bother anybody?
No, we got two different percentiles.
I told you to compute the 90th percentile. What'd you get? 88, right? Well, it's okay if the same number is more than one thing. So 88 is the 93rd percentile. It's also the 92nd percentile, the 91st percentile, the 90th percentile, and the 89th percentile, right? So if you take all of the rows where an 88 occurs and figure out the percent from there, it's all of those things, right? But it's possible that, the 50th percentile, the median, is also the 75th percentile. That's possible in a really skewed distribution. If 50% of the data are at 3, but also 75% of the data are at 3 or below, then it's both the median and the 75th percentile. Okay? Everybody understand percentiles? All right? So to get there, we divided the data into 100 equal parts. Well, for other aisles, like quartiles, how many parts would we divide the data into? 4 parts. So quartiles divide data into 4 equal parts. each with 25% of the data. Now, if I had a board laying here and I had to chop it into 4 equal parts, how many cuts would I have to make? 3 cuts. So there are 3 quartiles. How many percentiles are there? 99. There are 99, because to cut a board into 100 parts, you got to make 99 cuts, right? Because you weren't at the 100th percentile for your math ACT score. Don't worry, there's only 99 of them. You can't be 100% of them. So there's 99%. There's 3 quartiles, and we call those Q1, Q2, and Q3. Q1 as a percentile would be what? 25. So that's P25. What about Q2? P50. And Q3? P75. So these are just percentiles, 25th, 50th, and 75th percentiles. Now, Q2 also has another name. It's so cool, it's got 3 names. It's also the median. Right? So how do you find the first and third quartiles? We already know how to find the median. How do we find first and third quartiles? Good. That's one way. There's 2 ways to do it. The book gives us 2 ways. The first way is use the percentile method, which we just learned. And that will give you exact values. The second way is to divide the data into 2 parts. Divide in half at the median. And don't include the median in either half. If you have an odd number of observations, the median is the exact middle number, so it gets left out of the lower half and left out of the upper half. Right? So you take each side of that. If you have an even number, the median's halfway between, so the median's not in the data anyway. So then you just take the lower half and the upper half. Find median of lower half, and that's equal to Q1. Median of upper half is Q3. Most of the time, these 2 give exactly the same results, but they can be different depending on, how many observations are in the data and whether or not you have duplicate observations and that sort of thing. They go through an example in the book where they are the same, and then they go through another example where they're slightly different. They'll never be very much different. Yeah.
So, like in the example earlier, you can have a median, and it can also be the 70th percentile. How would you split that into Q1 and Q2 then, since the median ranges?
You still do what it says, even though let's use this pulse data where we had a lot of 72s and they were the median, right? So I think I understand what you're getting at, but if I scroll to where I see 72 and the median was which observation? 183rd? Okay, so that was row 184. So I've highlighted the median row, right? The middle row. So when I divide into lower half and upper half, all of these 72s still get used. They're still in the upper half. So even if there was enough of them that they went to 75%, you'd still use them all, right? And you'd end up with the median of that upper half would still be that 72, so you'd get the 75th percentile, the third quartile, is also 72, right?
So Q2 and Q3 would be equal.
Right. Yep. Right? This can be very confusing, so I'm going to spend just a little bit of time, but suppose, let's go back to the frequency table that we had a minute ago. We had number of siblings, so something else, right? Well, I remember an example, and I'm laughing about it, but it's kind of a morbid example. But in our last textbook, they had a frequency table that said, number of people that you know who have been murdered. Right? And let's say they took a sample of 5,000 people. I don't remember what the N was, but it was several thousand. But, so, most of us would say 0. I've never known anybody that was murdered, right? Well, what if 4,000 answered 0? Now I got 1,000 people left, and maybe 1,000 or maybe 800 of them said 1, and then 2, there was 50. How many more do I need? 150. So 3. Let's make that 150, and then zeros like that, right? Okay. That's the beauty of making up your own data. Right? You can make it work. Right? So then 4 is a 0, and so on. Okay? What's the median of this data? What's the median? 0. Because half of the subjects answered 0. What's the 25th percentile? 0. What's the 75th percentile? Also 0, because 4,000 out of 5,000 is 80%. So 80% of the people said 0. So what number is sitting at 75%? 0. So all 3 quartiles are equal in a data set like this. If they are equal, then you know you have skewed data. Right? You know you have skewed data. So let's go back to symmetric data, the pulse data. And we see here, that we have 88, 72, and 64 for the, 80, not 88. I'm looking at Q3, median, and Q1. Right? So it's 80, 72, and 64. So then let me go to the picture of the histogram. And let's see, let's use this one. This one has bars of width 2. So the median was 72 right there. The first quartile, what was it? 64. Yeah. So 60, 66, 64 would be 62 right there. Right? And then the other one was 80. So that's right there, the edge of this divider. Okay? So if I draw a line up here, and a line up there, and so on, what percent of the observations fall down here in this tail?
25%.
25%. Good. That's definition of quartile. It's the 25th percentile, which has 25% of the data at or below it. Right? How much is in this sliver? 25%. And so on. All of these have 25%. So what percent of the data falls between the first quartile and the third quartile?
50%.
50%. Right? So from here to there is 50%. Right? So the amount of distance that it takes to get from the first quartile to the third quartile, or another way to say it, the amount of distance it takes to get the middle 50% of your observations is called the interquartile range. And it's a measure of spread. How far do I have to go from the median to get the middle 50%? So the interquartile range, which we abbreviate IQR, is equal to Q3 minus Q1. So it's the distance between, I never wrote my 80 on there, the distance between those two values. So what is the interquartile range for the pulse data? 16. 80 minus 64 equal 16. Now go back up to the software output. Notice right here it automatically outputs interquartile range 16. It's a measure of spread. What's another measure of spread? Yeah, range is a measure of spread. So what's the range of this data? I guess it's written up there. 86. Where's the 86 come from? Max minus min. 126 minus 40. All right. What's another measure of spread? Standard deviation. Good. And the standard deviation is 12.46. So interquartile range is never going to be equal to the standard deviation, but it's always in the ballpark. What percent of the data falls within plus and minus 1 standard deviation? 68%, if it's bell-shaped and symmetric. Right? What percent falls in the interquartile range? 50%. Right? So the interquartile range is sort of like 2 standard deviations, but it's not quite as much as 2 standard deviations. Right? Because you start in the middle and you go 1 standard deviation below and 1 above, you get 68%. You start in the middle and you go out to the interquartile range. Well, the interquartile range is the whole distance, so cut it in half, you get 8, a little bit less than the standard deviation. Okay, so then we got one more type of plot to talk about. Yeah, let's just erase this. And this is called a box plot. And a box plot is a really simple type of plot that gives you a good idea of the shape of the distribution and important statistics from the data, all contained in the box plot. Right? Its full name is box and whisker plot. I like that name better because I like to say whisker. It's a box and whisker plot. Right? So what is the box? What are the whiskers? Well, here's how it's done. And it's easiest just to use some real data and do it. But you start by drawing a number line. And the number line needs to be marked off so that it will accommodate your data, the minimum and the maximum. So my min was 40, my max was 126. So I need a range of about 40 to 130, and I should have it covered. Right? So mark off 40, and then we'll say 10, or 50, 60, 70, 80, 90, 100, 10, 20, 30. Okay? So then I'm just going to label every other one. Like so. Then you take this is known as the 5-number summary. The max, the 3 quartiles, and the min. 5 numbers called the 5-number summary. And they are what gets graphed in a box plot. So you start with the middle 3 numbers, Q1, median, and Q3, and you mark them on your number line. So that's 64, 72, and 80 for the pulse data. So 64, if that's 70, 64 is about right there. And you draw the left edge of the box. So I'll put a vertical line. And you don't have to do this, but it's nice, and at least for this discussion, I'm going to label above what exactly that value is. And then I'm going to go to the 3rd quartile, which is 80, and draw the other edge of the box. And the box part of the box and whisker plot goes from the 1st quartile, Q1, to the 3rd quartile, Q3. And then in the interior of the box, you mark the median with another vertical line. So the median is 72. That would be about right there. Right? So this is 72, which is the median. And then right there you can see, oh, the middle 50% of the data falls in that box. Then you draw the whiskers out to the min and the max. So the min was 40. The max was 126. So there's your box and whisker plot. Now, a lot of software will produce what's called a modified box and whisker plot. Our book doesn't talk about it, but what it does, the software will identify outliers, and this 126 would definitely be an outlier, and it draws the whisker, it stops the whisker at the last non-outlier, and then marks with some special character the outliers. So here's an example from, I believe it's the height data of males and females. These are what we call side-by-side box plots, and there's a little box down there, so that's an outlier. So there was a female that was 56 inches tall, right? It gets marked as an outlier. The whisker stops at the last observation not considered an outlier. So you can say the middle 50% fall in about, what, 63 to 67. The median is in the middle of the box. Whiskers are about the same length. That's symmetric data. Here's what do you think a box plot would look like if you had skewed data? One long whisker, one short whisker. Remember the age data? Very skewed. There's the box plot. So here's the box. Middle 50% of the people fall right around 20. One really short whisker down to 18. And one really long whisker, and then a whole bunch of outliers. Now, the regular box plot that our book would just make that whisker go all the way to that 87-year-old up there, or 89, or whatever it was, right?
How do we determine outliers?
I'm not going to... He just asked, how do we determine outliers? And there's different ways, but think of if you're 3 standard deviations outside the mean, you're an outlier. So you could do it that way. That's not how it's done here, but this book doesn't teach that, so I'm not going to go into it. There's one more topic, and I've got 15 seconds to do it, but we've already done it. And that's z-scores. Right? So we talked about z-scores before, but you're going to have homework problems. Z-score is x minus the mean divided by the standard deviation. It's a measure of relative position, and what are the units? Technically, it's unitless, but it's number of standard deviations. Right? So if somebody was had a pulse of 90, we would take 90 minus the mean, divide by the standard deviation, and we'd find that they're about 2.8 standard deviations above the mean. So it's a way of comparing different distributions to say which value is more extreme relative to their distribution. Okay? So it's a measure of relative position. All right. That's all I know about that. We will see you on Friday. Don't forget, tonight you have 3.2 homework due. Both of them. There's an A and a B.